Hey, 1010, how are you guys? Sorry I'm not there. Hope to see you Friday. Should be there Friday. But anyways, this is activity 5. This is the last activity in this unit. So next time we meet, we will be doing a unit review. And then the time after that will be the unit 1 test. So make sure that you're going back and reviewing through these first 5 activities. Like I said, we'll be doing a unit review on the next time, and then the time after that, which will be next week, we will be doing our first unit test. So hopefully everybody is squared away, they're feeling good, and we'll be able to answer lots of questions, and you can come in for flex next week as well for extra time. I'll probably even be around after school if you want extra time there. So lots of opportunities to get help, but you guys are going to do awesome. All right, so we are factoring, and we're factoring polynomials. This is where we unmultiply them. Instead of multiplying things in and distributing, we're kind of dividing things out. Now, this first couple of pages in the activity book is a lot by modeling. You can read through it, kind of work through it if you want. Have fun. But I really want to get into the second page here is these difference of squares. These are kind of our math formulas here, and then difference of cubes. So these kind of sit in the same category here. Okay. Use these, but we need to make sure that we have them memorized really well. A couple things that I really like to look at in the difference of cubes. So the sum of cubes, it's a sum because this is addition, right? If we have addition here, addition is in our first one, and then it's minus plus. Okay. So in the difference, we have minus, and then it's plus, plus. So they all have 2 addition signs in our answers or in our factored form. And then sorry, I just got that text offering me a coffee. I don't even know who that was. So don't drink coffee. Anyways, they all have 1 subtraction sign and 1 positive sign. So the first sign that we're looking at is always going to be the same as our distributed form, right? And then it's always going to end in a positive. So the ones that are changing are the first one in the first parenthesis. So this one here, or this one here. Once again, they're always going to have the same amount of 2 positives, 1 negative. It just depends on where they're at. Hopefully that helps. Hopefully it didn't. Anyways, make things too difficult. Okay, so there are a lot of example problems on here. So I will do a few here, but then I'm going to switch over to the printed assignment, which has a lot of examples that will be similar to what you have in your Alex Newton. And I'll do some there as well. Okay, so we are going to be dealing with, sometimes they're not just squared. Sometimes we're going to be dealing with multiple variables. But when it breaks down to it, we're going to do all of them basically the same. We're going to have 2 different methods in solving this. We're going to do our traditional X method, which in the top is our A times B. Well, actually, that's a lie. A times C, and then down here is our B, and I'll go over that. And then we're going to have some that have, like this one right here, that have 4 terms, and we're not going to be able to solve it with the X method because all the terms are different. We're going to do, this is called a factor by grouping, and it will say specifically in Alta Newton, which method to use. Okay. So sometimes we need to factor, and we're going to factor out greatest common factor as well. So 3 methods. Okay. So we'll be doing, all right, let's just kind of start. Whenever we started working with these, we have an a value, a b value, and a c value. Now the a value is always multiplying our variable squared. The b is always multiplying the variable to the first power, and then our c is always our constant. Okay, so in this top one, we've got a times c. So in this case, 1 is a. C is -6, so we've just got a -6 up here. Okay, and then in the bottom, we got a -5. So what we're doing is we're looking for two numbers that their product, or when they multiply, their product is -6, and their sum, or when they add together, is -5. And there is only one set that will work. Okay, now when we have -6, right, it could be 1 and -6, it could be -1 and 6, it could be 2 and 3, well, and then -2 and a +3. So there's lots of that could work for the multiplying part or the product part, and there's an infinite amount that could work for the addition part, but there's only going to be one set that matches this exactly. So if we were to add these two together, so add, right, well, that right there, that first one equals -5. So that's what we want. So we've got a +1 and a -6. Right? If we were to add these two together, that gives us a +5. If we're going to add these two together, it gives us a -1. And this one gives us a +1. So there's only one set that works. Okay, when we get to this point, we're going to separate them. So y plus 1. And then in our other binomial, we're going to have y minus 6. And this one, we're done. Okay. When our a value, our first number, that coefficient of the squared is 1, there's no more steps. We're done. Okay, where it gets a little bit different is where it's not 1. Okay, let's do a kind of an example here. First things first is I would always, if you have a negative a value, just make it positive. And what we can do here is we can actually factor that out. So if we factor this, we can put that negative on the outside, and that changes all of our signs. And let me get rid of this x, and we'll put it in a different spot. Okay, and what that allows me to do, and why I want to do that, is, and that's okay. It's going to be part of our answer. Our answer is going to be negative, and then we're going to have a binomial and a binomial. We got to make sure that negative is still there, but we can kind of ignore it now for the rest of the problem. Okay. All right, so we got 6 and 25. We multiply those together. That's going to give us 150. And then add together, our sum is going to be 25, as I read to 22. Okay, there are lots of factors of 150, right? We got 1 and 150. We got 2 and 75. It's divisible by 3. That's 3 and 50. That's not divisible by 4. It is divisible by 5. I think that's 5 and 30, right? So we're getting closer because 5 and 30 added together is 35. 6 is in there. 7 I don't think is. Well, it is divisible by 6. It's not 6. We're going to get to 10 and 15. That's our magic number here. Okay, I'm running out of room. I am going to white out the one below, so I've got a little bit more room to work. Just so. I'll actually do 2 videos. I'll kind of do one here, and then I'm going to work through a bunch of the problems in another video that are on like the activity 5 assignment, just so that we, if you want to watch it, you can. Oops. Okay. All right. So we've got a plus 15, a plus 10, but our a value in this case is not 1. So I am not done. Okay, so what I've got to do is I've actually got to divide these numbers by my a value. In this case, my a value is 6. Okay, and this is called the bottoms up method. There are lots of different ways to factor. This is the one I personally like, so this is the one I'm going to teach. If you have another way that you like and it works and you're comfortable with it, do it. You don't have to do it my way. Okay, so when I get to this point, I need to simplify. Need to simplify fraction. Okay, so I've got a plus 15 and 6 are both divisible by 3, so I've got 5 over 2. And then on this one, 10 and 6 are both divisible by 2, so I'll get a plus 5 over 3. And that looks terrible, so let's fix that. Whoa. Well, I am going to maybe try this one more time. Be super careful. Yeah, that don't work. So I'm just going to do this. Actually, let's do this. That works. There we go. Okay. 10 is divisible by 2. That gives me a 5. And then 6 is divisible by 2, which gives me a 3. Okay. And then our last step is the bottoms up. We're going to take that bottom number and we're going to move it out here out front. So we still have that negative because I factored it out earlier. So I've got 2a plus 5 and then 3a plus 5. And that is my factored form in that question. Okay, there's a lot there. Okay, so let's do another one. Okay, once again, I am going to white out this one down below, and I wanted white, so let's white that out. Let's go back to small, and let's get this color. I like it. Okay, so another thing that we need to do is we need to figure out if there's anything that we can factor out beforehand. Okay, before we do the X method, we do need to find a greatest common factor, if there is one. So in this case, we can divide all of these numbers by 2. So I have a 2 now here on the outside, leaves me a 2n squared plus 3n minus 9. And then these are the numbers I'm going to use for my A, B, and C values when I factor. Okay. Can't forget about this too. It is going to be part of my answer. So don't forget this. That's a big deal. Okay. All right, let's do it. A times C, so it's going to give me a negative 18, and then I have a positive 3. So factors of 18 are 2 and 9. There's a difference of 7, so neither one of those is going to work. And then I'm going to have a 3 and 6. So I got 3 and 6. And then my 3 is going to be negative because 6 minus 3 is going to be a positive 3. So I've got 2 and then n minus 3 and then n plus 6. My a value is not 1, so I do have to divide by my a value. This 3/2 is simplified, so I'm going to move that up. So 2, and then 2n minus 3. And then on this one, 6 divided by 2 is 3, so I'm going to have n plus 3. And if you think about it, 3 is just 3 of 1. If I do move that up, well, it's just not something I write. So 2n minus 3, and then n plus 3 is my answer. Okay, I am going to, let's look at actually the one above. So this one right here, this one is a difference of squares. Okay, because I can take the square root of this, and I can't take the square root of negative 64, but I can take it of 64. And these ones are pretty simple when we do find them. It's because m, and then it's a plus and a minus. And then the square root of 64 is 8 and 8. And there we go. They just follow that pattern from above, which is this one. Okay. All right. So let's do a factor by grouping. And I am going to get rid of the one below it. And there's another factor by grouping, so I'll get rid of a couple. I don't want to do that one. I can do the one. Oh, God, it didn't change. So let's come here. Yeah, there's a lot of good ones on this one. So yeah, let's just start there. Actually, I hadn't even done the one I wanted to. Let me get rid of that. Okay, so back here, we'll go small, blue. Okay, so factor by grouping is, they're going to start a lot on ones that have 4 terms. And what we're going to do is we're going to factor out the first 2 terms, factor out the second 2 terms, and then we should have in our parentheses the exact same thing, and that allows us to factor out. And before I actually get to that, I actually want to do this bottom one because it's already factored that way. Okay, what I have is I have x squared, and I'm timesing this unit right here. So what I can actually do is bring those out. Remember that 25 is just the number 25. It's not part of the problem. So I've got that x plus 3, and then what I have left is x squared plus 25. So that comes from there, that comes from there. So this is what we're trying to do with the factor by grouping. And so I'm going to take each one of these. Okay, what I have in common between the 5v cubed and the 4v squared is a v squared. Okay, so what I'm left with is 5v and then plus 4. All right, and then my pro tip is on these, I know for a fact that these need to match. What that does is it allows me to look at the numbers above and see what I need to divide out. Okay, so I got a negative 20 and I need it to equal 5, and then a negative 16 and I need it equal to 4, and they need to, the same number needs to divide out, and that works out as negative 4. Okay, so that leaves me with the 5v plus 4 in my first parentheses, because that's what I have in common with the 2, right? These are the same. And then I've got a v squared minus 4. And they go pretty quick that way. Okay, let's do one more of those, which is right here. Split that down. So this one I do have a 6x squared in common. So that leaves me with 3x, and then 6x squared divided by 6x squared. Well, that's just 1. That's okay. That's actually great. Here, I need to have the exact same thing. Okay, so if I have a negative 5, I need to divide it by something to get it. I know it has to be negative 5, so here I'm going to divide by negative 5. And that leaves me with a positive 3 and a positive 1. So that's a 6x squared minus 5. And then 3x plus 1. And that's factoring by grouping. All right, so let's look at this first one. You might think, well, there's not a squared term, and you're kind of right. So this is a greatest common factor. Let's see, greatest common factor. So I've got a 2, but then I also have a z that is factored out of both of them. So I'm left with 2z minus 3y. And that's factored. That is done, right? I can't do anything else there. Okay, this next one is a difference of cubes. Wow. And that's because the cube root of 64 equals 4. So this is where I go to that couple pages before, because it's a difference. It's going to be in my binomial, it's going to be minus, right? Minus, and then it'll be a plus, plus. So I take my a term, my b term. I need to know what those are. So in this case, well, let's set up my, so I know that this one's minus because it's got a match, and then it's going to be plus, and then it always ends with a plus. So I've got a, and then the cube root of 64 is 4. So then I got a squared, and then I'm going to multiply the a and the b together. So that's going to give me 4a. And this last one is going to be the b, which in this case is 4 squared, so 16. And that just follows this. And I don't like how they used a here, but a minus b, a squared, plus ab plus b squared kind of form. Okay, there's a lot of steps to this one. So I'm going to factor out an r squared. So that leaves me with r squared minus 4. And you might think, we're done. Well, you're not. Okay, this is the difference of squares. Okay, so that's going to be r squared, and then I've got r minus or plus 2, r minus 2. Now you're done. Be sure you're factoring everything out that you can. This one you're going to factor out of 4p. And then so it'll be p squared plus 16p. And then that's a big number. I just use a calculator. Do 252. Let's see here. Grab my calculator. I'm just doing it to the side. 252 divided by 4 equals 63. Okay, so we do our, so I got 63 up here. I got 16. It's 9 and 7. So it would be 4p, and p plus 9, p plus 7. That looks great. This one, we can factor out a 2. So there's 125a cubed plus 1. And 125 is a perfect cube. So 2 is still part of our answer. And then because it's plus, that'll be something minus plus something. And in this case, 5 cubed is 125. So we've got 5a plus 1. Then we'll have 25a squared. And then 5a times 1 is minus 5a. And then this last one is just 1 again. So we need to be able to see and kind of recognize those perfect cubes, because there's going to be a lot of them, including this one. I'd factor out the negative. In fact, I think both these are divisible by 3. They are. Let's see, because that leaves me with, let's see, 20, let's see, let's do a negative 3. So it's 27a cubed minus 8. So it's negative 3, and then I got my differences. So the difference plus, the cube root of 27 is 3. So that's 3a. Cube root of 8 is 2. And then that'd be 9a squared, 6a, because I'm timesing those two together, and then 4. Whew, this is awesome. There's a lot. Okay, let's do one more, because I think you'll see these come up, is I've got an x to the 4th and x squared. And I'm just going to do the x method with this, and the only difference is in my answer. I'm going to have an x squared terms here at the beginning. And that's it. Okay, so I got negative 5, negative 4, so that's going to give me a negative 5 and a positive 1. So x squared minus 5, x squared plus 1. And yeah, that's kind of the gist. There's a lot of factoring, so there's a lot of practice. This is a long assignment, so just get on it. And like I said, I'll be there on Friday, and we'll talk to you later.